Okay, so this is calculating a correlation coefficient as well as the coefficient of determination and interpreting them both. So this example has to do with age and weight of Shetland ponies. So X is the age and Y is the weight, and if you've got a grapher, enter the X's into list 1 and enter the Y's into list 2. Enter them in separate lists. If you've got maybe this guy, then it can do two variable statistics. You have to go to your second, well, you have to turn it on first, don't you? You have to go to your second stat key and you have to select to var. I'm not going to do it because I've already entered my data. And then you have to go back to data and enter two variable statistics. See my handouts or my video on playing with this guy. So what I'm going to do is I've already entered everything into this calculator. I'm going to use this one instead of my grapher to illustrate that this guy can do some stuff. I'm going to go to, let's see, stat bars, like that. And once you get the data entered, you just hit the stat var key, or statistical variable key, and it goes over and it shows you all the cool stuff about X and Y, which in this case we don't need because we only want Pearson's correlation coefficient. Now here's A. That is has to do with the equation of the line, and I've made a note on my calculator in blue Sharpie because this calculator uses A as the slope and B as the Y interval in the equation of the line, which is backwards to what many statistics books do, so it creates confusion. So I had to write the equation that they use. They use AX plus B. A lot of books and statistical applications and statisticians use Y equals A plus BX. Okay, so there's a little bit of confusion there, so I have to write it on the face of my calculator or I get confused because I don't normally use this calculator, and this calculator is kind of backwards from everybody else. But we want R, so right here it gives us R, so I'm just going to write it down. I'm going to write down everything that I see. So 9, 7, 2, 2, 4, 6, 0, 8, 4. Never hurts to have a lot of decimals. Now I'm done with my calculator for now. I can put it away. And I'm ready to interpret. And the interpretation goes, the correlation coefficient is, and you put down what it is, and at this point you can round depending on what your instructor requires, which indicates A, if it's close to 1 or negative 1, it's strong, and this is really close to 1, so we're going to say strong. If it's negative, it's a negative correlation. If there's no symbol here, it's assumed positive, so it's a positive correlation between the X variable, which is age, and the Y variable, which is weight. And that's the interpretation of the correlation coefficient. I'm going to bring this guy back up because now we want the coefficient of determination, which is R squared. Now you can either manually enter this number and then square it using your squared key, or you can go back into stat var, scroll all the way over, which takes a while, and he appears there, and then from this menu I can actually square him. And he says, oh, you want to square R? And I say, yes, I do, please. And it squares it for you. And you just write that down. I go ahead and I write down everything that I see, but I can't see it when it's on the screen, so I have to bring it over here. 2, 6, 2, 4, 8, 8. Okay, so big decimal. And now in my interpretation, I'm going to convert this big giant decimal into a percentage. I'm going to go 2 decimal points in my percentage, so 94.53% of the total variation in your Y variable, which is weight, is explained by the X variable, which is age. And that is the interpretation for the coefficient of determination. And that is all you do. And again, you can get these numbers very easily using a graphing calculator as well. See my tutorials on linear regression using the graphing calculators if you're confused or if you don't know how to get the numbers to come up with your graphers.